So looking at the sleep example, we had 185 students. We're going to assume the true standard deviation is 2.5 hours. So what's the rejection region for the test and what's the power? So once you got the rejection region, then you can get the power. The first step in getting power is to work out your rejection region. And then once you got your rejection region, you can say, well, how often under the scenario that the true mean was 6.5, how often would I end up being in the rejection region? So to work out the rejection region, we need to think about the alternative hypothesis. So our null hypothesis was that the true mean 7. Our alternative hypothesis is that the true mean is less than 7. We know if there's evidence that the true mean hours slept by students is less than 7. Okay? So the rejection region is going to have to be, it's going to be a one-sided thing. We're looking for sample means that are less than some critical value, less than mu naught minus z star sigma on root n, where z star is a value from the standard normal distribution such that the chance of getting less than z star is 5%. Okay? We can ask MATLAB what it thinks. Good morning, MATLAB, how's it going? It didn't even answer, it's quite rude. Anyway, minus 1.65. So what that tells us is that if you've got a normally distributed variable, 5% of the time you get more than 1.65 standard errors below the mean. So that if we're going to reject at the 5% level, if we're any further than 1.65 standard errors below the mean. So the hypothesized mean, I should say. So the hypothesized mean was 7. So we subtract off 1.65 standard errors. The standard error in this case is 2.5 divided by square root of 185 if we're talking about a sample of 185 students. What does MATLAB have to say about that? Okay, so we're going to go 7 minus z crit times 2.5 divided by the square root of 185. I did something wrong. Probably should have been plus, I reckon, because I did norm inf of 0.05, which gave me a negative 1.65. So plus negative 1.65 times 2.5, yeah. All right, so that's x bar's got to be less than 6.698. So that's our rejection region. What's the power? All right. The power is going to be the probability that the sample mean is less than 6.698. If the alternative hypothesis is true, where the true mean is actually equal to 6.5. So what we're going to do now is we're going to say, this was, all right, I'll draw a new graph for you. So under the null hypothesis that the true mean is 7, we think sample means are centered around 7 with a standard error of 2.5 on root square root of 1.85. What's that equal to? All right, so what's that equal to? 2.5 over the square root of n, that's 0.184. So we decided that if the true standard deviation is 2.5, you got a sample size of 185, the next bar is approximately normal, centered on 7, with a standard error of about 0.184. Okay? That just comes from this result. X bar is approximately normal with mean mu, standard error sigma and root n. Sigma and root n in this case is 0.184. And under the null hypothesis, the mean is 7. And we worked out that our critical value All right, so our critical value is 6.698 and our rejection region is here. We're going to reject for any sample means less than that. Now, we're asked, what if the true mean were 6.5? Here's 6.5. So we're going to be under the alternative hypothesis, and we're specifically going to say, what if students are on average getting 30 minutes less sleep than is recommended? We want to know what is the chance of being in the rejection region now. So what we're doing now to get power is we're saying, what's that? Yeah, so under this alternative hypothesis, we're saying that the sample mean is approximately normally distributed by the central limit theorem, but now we're saying it's centered on 6.5. Same standard error, 0.184. So, this is actually a straightforward normal distribution calculation once you're at this point here. I mean, we've talked before, back in week 3, we talked about how to calculate normal probabilities. What's the chance that x is less than this for a normal distribution with this mean, this standard deviation? That's what we got here. That's all we got. Look, what's the chance that x bar is less than 6.6984 when x bar has this distribution? It's not hard to do, really, is it? So we're going to go, that's equal to, one way to do it is to standardize, to go, I'm going to x bar minus its mean, minus 6.5, divided by its standard deviation, 0.184. And once we've subtracted off its true mean, at least its true mean under this hypothesis, and divided by its standard error, we get a standard normal. So now we got probably that the z is less than whatever that guy is equal to. MATLAB can help us with that. We'll go, all right, so this was x bar, the critical value for x bar was 6.69. So I'm going to go x bar crit minus 6.5 over the standard error. Gives us the answer 1.075. To get this area to the left, we just use the norm CDF function, don't we? So I'm going to go norm CDF of this guy. That'll give me the area to the left, and the answer ends up being 0.8589, 0.859, about 86%. So if the truth was that students on average get 6.5 hours sleep, 30 minutes less on average than the Sleep Foundation recommends, then for a sample size of 185 people, where the true standard deviation is 2.5, you got like 86% chance of seeing that effect. So 86% of the time when you take a sample of this size, you're going to see that students aren't getting enough sleep. So I reckon that's a pretty good test to have that much chance of detecting an issue.